here we are in Urbano, and as you can see, I don't have any drawing open yet. And the best way to open existing Urbano project is that you first run Urbano. So don't just double click on DWG, because first of all, Urbano has to load with all the functions, and then go to File, Open, and standardly open your file that you want to open. Or the way that I like to do it, so just take the DWG file and drag and drop it to command line. So that's the way. Of course, even if you okay, here I don't have the raster that I had yesterday, so I will just repeat this procedure. So here I have the training from the day one, and I will take this TIFF files also and copy it just to day two. So we have the same example as yesterday, and we are continuing from there. So it's not a problem if you just double click on the DWG file. Everything should load correctly, but the suggested way, the recommended way would be to first open AutoCAD or Civil 3D with Urbano loaded, and then open the file. So here is where we left off yesterday. We have our system that we designed yesterday. We have our profiles, and we have our cross sections. So today, first time we will see the Hydra panel. Like I said, here on the left, we have our module selection. And today we will talk about the Hydra panel, where we have all the functions related to hydraulic calculation. So first function with which we will start today is the function for setting air release and washout valves. So let's take a look into this function. So if we open it, you will see that we can define here air release valves and also washout valves or mud release valves. And also you can see that we have two ways how you can set this equipment. First way is by automatic setting, and the second way is by single or interactive definition. Let's check first the single, which means interactive selection. And now you can see this part of the dialog is grayed out, and we have the interactive setting. And now you can select your nodes in plan or in profile. So you can set it in plan, but always it's better to set it in profile, because here you can see where those equipment should go. For example, let's go to this node here, and let's define this to be, because this is the slope is changing from positive to negative, so we have an inflection point, and here I will place a washout valve. So just select it and click on apply, and you will see that this custom block or this custom graphics will appear here, suggesting that here we have a washout valve. Let's also find one good point, for example this one here, to place one air release valve. So let's select air release valve from the list, and let's click apply, and you can see again this custom block or custom graphics automatically appears here. If you want to delete it, you see there is no delete button, because you're basically not deleting, you are changing the node type. So we can change it back to plain node and just click apply, and now here we see that we have the plain node and no graphics. The other way how you can reset everything at once, you can switch to automatic function, and now we can select all the nodes, so the whole active system, and we can define here set type to node, which says replaces all air release and washout valves with the ordinary nodes. So we will set everything to node. And also let's now check this automatic function. Here you can see that you can automatically set air release and washout valves, and here you can see that it can be applied to all types of nodes or just to ordinary nodes. Let's see what does this mean. First of all, I will select all types of nodes and I will click apply. Okay, let's now check the result. Here you can see, here we have a air release valve. Here we have mud release valve or washout valve. Here we have the washout valve. So the software is automatically checking for highest and the lowest points in our network. And on the highest points, it automatically places air release valves. And on the lowest point, it automatically places these washout valves or mud release valves. So basically, it searches for the inflection points in the network where the slope is changing from negative to positive or from positive to negative. Also, I will show you this really nice function, the search function, where you can select any node in plan or in profile. Select, for example, this node here, and we will automatically zoom to plan, and we can see that here the graphics, this custom block, automatically also changed and updated with this symbol. Of course, this can also be customized and changed, that symbolizes air release and washout valves. And also we can zoom back to profile as well. Okay, and also let's check now the first node of the system, this node here, and you can see that the software also placed here we can see the air release valve. So let's now set a water tank, and we would like to set a water tank to this node here. Okay, to set water tank, we have to go to the second command on the Hydra panel, which is called hydraulic node equipment. So if we run this command, you will see that here we have all the EPANET available network elements. So reservoirs, tanks, emitters, all the 6 available EPANET valves. So pressure reducing, pressure sustaining, pressure breaker, flow control, throttle control, and general purpose valve, and also a pump. As you can see, the valves and the pumps in Urbano are basically nodes, junctions, and not like in EPANET links, but everything is completely connected with EPANET. You will see that later. And also, let's here select this water tank, but first of all, we have to select where. So again, you have this icon for selection. Let's select this node here. And now from the list, let's select water tank. And here you can see that you can set up all the parameters for the tank available in EPANET. So we will set everything as default. So initial water level will be 3 meters, minimum 0, maximum water level 6, and tank diameter will be 15 meters. Let's click apply. And notice now that in the same node, we have both water tank and also air release valve. Also, if we check our data tables, let's expand it a little bit. Let's switch here to node hydraulics, and let's select this node. Here you can see that hydraulic equipment is set to tank. But if we switch to node geometry, you can see here that the node type is air release valve. Okay, let's now go back to our function for setting air release and washout valves. Let's select the entire network and let's set everything to node. So let's delete all the air release and washout valves. Okay, and let's now select the whole system. And now we will switch here from all types of nodes to only ordinary nodes. And let's click apply. And now you can see that the software automatically placed air release and mud release valves, but not in the nodes that are not plain nodes, that are, for example, pumps, water tanks, reservoir valves, and stuff like that. So we still have the air release and mud release valves, just that those hydraulic equipment nodes are skipped. Okay, that's it. Let's now also place this air release and mud release valves to be inside of a manhole, because yesterday I showed you how you can set the manholes from the manhole catalog. So let's now repeat this procedure. I will go to function for setting the manholes from the catalog. I will use the same manhole as yesterday. You can see how the software remembers the last used manhole and all the last used setting. And now, of course, we could go and select just the nodes that where we would like to place these manholes. Or I will use the another way. I will go to select all the whole active system, but I will use node filtering, and I will filter it by node type. And here I will say all the air release valves. Okay, and I will click save. And you will see that here we have now a manhole, and this air release valve is placed inside of a manhole. And here you can see that here the software didn't set the manholes because we used the filtering. Also, let's select now a filter for washout valves. Let's click save, and here the manhole will appear. Okay, so now we set up the water tank and also air release and this mud release valves. Now I would like to save this drawing. Let's save it, and I will save it as working 2, like working from day 2. Let's click save. Okay, and now I would like to open another drawing where I would like to show you some other features about this air release and washout valves in connection with automatic positioning of pipe invert or pipe elevation. So let's take this drawing, let's open it. Okay, here we have one already designed water distribution network. You can see how the network looks in plan. We have all the regular nodes, and you can see this style is applied with realistic pipe dimensions. And we can check this system in profile, but you can see we cannot see the pipes in the profile because we have no invert elevation defined. So if we check our data table for section geometry, you can see the pipes are set from the pipe catalog, but invert elevations are empty. Okay, let's now go to function for setting the invert elevation. So let's go to input data. Let's go to invert elevation. I will use the function for constant depth below terrain. So constant depth below terrain, referent pipe point. So like I said yesterday, I will use axis, but you can use, for example, top outer if you want. So I will set the axis, meaning the center line of the pipe will be 1.5 meters below the terrain. Let's select the entire network and let's click save. And now you will see that the pipes will appear on these positions. And also here you can see that, like I told you yesterday, any data from Urbano can also be added to the profile table. And here you can see the node type, and we have everywhere the plain node. Also, if we open our data tables and switch to node geometry, you can see that the node type is everywhere plain node. Okay, let's now go to our function for setting the air release and washout valves. Let's select the whole system and let's use automatic option and click apply. And now you see how everything is completely dynamic. And now you see how the software inserted a lot of these air release and washout valves with these graphics. Because we placed the pipe to be on a constant depth below terrain, we have a lot of these inflection points. So if we check it in the data table, we will see that in total, we have 17 air release valves. And if we sort it in reverse, we can see that we have in total 16 washout valves. So how we can automatically reduce this number of unnecessary air release and washout valves? So we have on a main panel, so if you click on your home panel, in the workspace, you will find automatic invert calculation function. You can open it. You can create new configurations as well, but I will open this one, which is a default. Let's just double click on it. And here you can basically position the pipe so it follows these rules that can be set up here. So minimum depth below terrain will be 1, and this is the minimum depth of the pipe below the terrain. So this will be the layer above the top outer point of the pipe. So 1 meter above the pipe. Maximum depth below terrain, let's leave it to 2 meters. And also you can define minimum slope. And here minimum slope doesn't mean a minimum positive slope. This is the minimum, how should I say it? Minimum positive or negative. So absolute value of the slope, because we don't want our pipes to be horizontal. So we will set some minimum slope to be, let's say, 1 per mile. And additionally, if the software cannot satisfy these rules, the software can additionally convert additional points, so the points where the pipes is crossing the triangles of DTM, to new nodes. So the software can automatically insert new node, but I will leave this option turned off. And also I will use this option, set air release and washout valves automatically, meaning if this option is turned on, the program will automatically set air release and washout valves. And how this function works. So basically the function satisfied these rules, minimum, maximum depth, and minimum slope, but it is also optimizing and minimizing the number of inflection points. So let's check it. Let's select the entire network. Let's click calculate, and you see how this will be our position of the pipe. So let's click apply. Let's click save, and now take a look. This is the new solution of the our pipe position, and you can see that we have a lot less now amount of air release and washout valves. So the software placed our pipes to be on a range below the terrain between 1 meter and 2 meter, but it reduced the number of unnecessary inflection points. And it automatically placed air release and washout valves just on those places where they need to be. So let's check this node, for example, in plan. And here you can see, here we have a washout valve, here we have air release valve. But the total number of air release and washout valves is a lot less. So let's check here in our data table. Let's sort it again. And now you can see we have just 4 air release valves and we have just 4 washout valves. So really nice function for optimization of your pipe position with reducing the number of necessary air release and washout valves. Okay, and also I had some, I wanted to show you this procedure, how the number of air release and mud release valve is reduced. So, but this function can also be used even if you don't have the pipe elevation set at all. So you can have empty, empty profile, no definition of the invert or pipe elevations, and you can just run it from scratch. You don't have to have something to be optimized. You can just run it from the empty profile. Okay, so we are done with this example. I will save it so you can have it as well. I will call it just final, like this. And now we will go back to our main drawing, where we will now talk about setting water demands.